Hello everyone, this is Mohammed from Python Ninja YouTube channel, and in this tutorial we will learn together how can we design a prime number function that will use as a filter to extract a prime number from a series of natural numbers. So in this exercise we will build a Python function that will return to us a prime number, and we will write a Python program that will print the prime number in a range of 2 to 1000 or whatever the limit is. And we want to introduce the meaning of the prime number, or what is the prime number. A prime number is the whole number greater than 1, so our sequence will start from 2, whose only factors are 1 and itself. So in general, a prime number is a number that doesn't accept any number to be as a divisor, okay, or dividend, other than 1 or itself. For example, 4 accept 2, so we can divide 4 by 2 and we will have integer, okay, and by this case 4 is not considered as prime number. So again, prime number is the whole number greater than 1 whose only factor are 1, so it accepts the division by 1 or by itself, okay? So all even number cannot be accepted as a prime number because it accepts the division also by 2 at least, okay? Before start coding, I want to briefly introduce filter. Filter is a function in Python. It is a built-in function, okay? And this filter is used with a series of numbers and functions. So when we apply a function to a sequence, if this sequence is a list or a string or any sequence data type, as what we learned together, okay, we can apply this filter, and the first argument for this filter will be the sequence, okay, and the second argument will be the first one will be the function, the function that we designed, and the second argument will be the sequence of the numbers or the sequence of strings or whatever. So this is the syntax of filter. We will have a separate tutorial about filter and reduce and map and so on later after introducing files in Python tutorials. We will highlight these filter, and even after the object-oriented programming we will describe the filter function in a separate tutorial, but we will use this in its low basic form. So we will design a function, okay, and we will pass this function as the first argument to be applied to a sequence of numbers to extract the prime numbers, okay? So in general, I can say I have the natural number, okay? Natural number. See, this is the all numbers, we call it natural number. This will be range, and this range, because I work with the prime numbers and prime numbers are greater than 1, so I want to design a sequence that starts from 2 and stop to 1000 as what the program asked me. If I want to print this natural number just to see, I have to unpack this range. We cannot print this as it because it will show the memory address or the object or the range of 2 to 1000, but we can unpack this, okay, into a list, okay, and by this way we can print the list of numbers, okay, the list of whole natural numbers including the prime numbers, okay, and non-prime numbers, okay. This is the whole series from 2 to 1000, okay. So this is the first argument we need, and we need also to design a function. Let us design a naive function that will only just return true. So it will accept this number and return it true, and accept this number and return it true, and we will pass this function into filter. So with filter, we will have like a sequence and a function that will return true or false just to select this number. So let us define, for example, not nums, okay, which are the natural numbers, and this natural number will accept none, okay, so it will accept for the example this number or this number, okay, and this function is naive, so it's very basic, and this will return only true, okay. So if it accepts any number, it will return true, and I can recall the function now, which is the not numbers, okay, and for this not numbers, it will does nothing because it will be like series of a true or false. For example, let us print this not number, okay, the function. We will see it will return true. If I pass any, for example, number, it will return true. How can I apply filter to this function, okay, or use this function that return true inside a filter, okay? So we can, for example, say natural nums, just to be different than this name, and this will be a filter, and this filter, as we said, it will accept the function first, which is the not number. Remember, when we recall the function inside the filter, we remove the parentheses or round bracket, we use only the name, and I use the sequence of numbers as a second argument, okay, which is the natural numbers. And yeah, I have this filter is applied, and now we have no error. If I want to print this result here, I will have a memory address. So what I have to do is to unpack this into a list to see the result, okay. So let us unpack this into a list, okay. We unpack this, and we have, this is the natural numbers, and we have now error, we have error because incorrectly I have the natural number here and natural number here, and I have to include the function name, not the sequence. Sorry for this mistake. And now we have the sequence of the natural number, okay, because this function only return true, and it will return to me, okay, by applying the function, it will return to me a sequence, okay, of truths from 2 to 1000 here, okay, and to 1999 here, okay, and this filter will take this true and take the number. If the number is true, okay, then it will put inside the list, okay, then it will go for 3 is true, then it will extract this, okay. Now, how can we use this in terms of prime number? How can we apply this? Okay, so let us remove all of this and start coding the prime, okay, numbers, okay, and this will take number, okay. Now, as we said that the prime number are a set of numbers that or the whole number greater than 1 and only factor of 1 and itself. So if it will be a factor, if 2 not 1, then it is not the prime. So we can loop, okay, for I in range, okay, we will start from 2 to the num, okay. So suppose I have, for example, number 4, okay, then I will consider the loop from 2, okay, and 3, okay, as a range, okay, and we will take the remainder of the division, okay, and if it will equal 0, then it is not a prime number. Okay, so we will return false. So if this number, okay, the remainder of the division by I, okay, sorry, then it will be, if it will be 0, then I have to return, okay, return false. Okay, again, I like passed number here. Suppose I passed here 10. Okay, then I loop from 2 to 10, which will be 2, 3, 4, 5, 6, 7, 8, 9. Then I divide the number 10 into 2. I take the remainder of division. Okay, if there will be remainder or the remainder will be 0, then this is not a prime number. For example, here I take 10. Okay, the remainder of the division between 10 and 2, it is 0 because 10 modulo 2 will be 5, not 5.3. Okay, so it will be 5. So there is no remainder of the division. So we will return false, else return it true. Okay, so it's very simple. So by this way, we design a function that take a number, okay, any number in this range, and it will loop, okay, from 2 to that number, okay, and will check the remainder of the division. If there will be remainder, then it will assign false. So the filter, when we assign false, then the filter will not extract the number. Okay, so and I can here say, for example, if primes will equal, let us unpack directly, which is list of filter, and this filter will take the prime numbers as a function. Again, we will remove the parentheses, and then we'll take the natural numbers, and when I print primes, okay, then we will have the set of prime numbers which start by 2, 3, 5, 7, 13, 17, like this, and these prime numbers can be divided by 1, okay, without any reminders, okay, can be divided by 1 or can be divided by itself. Okay, so if I take a 3 divided by 1 is 3, divided by 1 is 3, and the 3 divided by 3 is 1, okay, but cannot be divided by 2, otherwise we will have remainder in the divisions or floating points, okay, in the division. Okay, now by this way I loop, okay, for each number of this sequence. So for 2 I loop, okay, and for 3 I loop in this range. For 10 I loop from 2 to 10. Suppose I reach for 999, it will come here, and I have to loop through from 2 to that upper bound, and I have to take this upper bound, which is 999. I divide it by 2, 3, 4, 5, 6, still reaching 999. This is like computationally expensive, okay, to check the remainder of this. However, we can use or utilize this to have the prime numbers, okay, to check how it's like computationally expensive, okay. Let us to check this function when we recall. For example, if I want to recall the function for a series of times, so let us import time, okay, and after importing the time, we want to set like start will be time.time. So by this way we can start our timer. Then I want to loop, okay, for in a range, okay, in a range, okay, I want to loop from 1 to, for example, 50 hundreds, okay, like 50,000, sorry, okay, and I want to recall this prime number, okay, and I will apply this into number, and later I want to have end, and end will be nothing but the end of the timer time. Then I want to print in the time which is the end, minus start. So just to test the performance and the of the prime numbers function, I have like a range of loop from 1 to 50,000, and I want to recall this function, and I want to assign a number to each function. Just I want to see how long this function will take to loop over 50,000 and return either true or false. And when we print this, and look at this square red button, the execution for this function to loop over 50,000 and recall this function that will return true and false. Even before passing this to the filter, it takes around roughly 8 to 10 seconds based on my computation or computational resource that I have. However, there is a method that is more efficient than this method, in which we can reduce looping, not to loop among the whole numbers. Let us just to clarify this more. So I want to move this description to up. So let us improve the computational time of the above of the performed prime function, or the previous prime function. So the above or the previous prime function was computationally expensive. Suppose I have, for example, a number 36. This 36 is equal to 1 by 36, or 2 multiplied by 18, 3 by 12, 4 by 9, and 6 by 6. If I reach any number that is a result of its square number, or equally numbers in the left and in the right, like in 36, we have 6 by 6. For example, in 16 we have 4 by 4. In 64 we have 8 by 8. In 81 we have 9 by 9. These numbers that have in its multiplications, that is a result of a multiplication of two equal numbers, we call them perfect square numbers. So these numbers are perfect square numbers, and I can limit the loop, instead of looping from 1 to the end of this number, or to among the whole range of this number, I can limit the loop to be to the square root of that number, and the result after the square root of this number, multiplied by the square root, will be repeatable. For example, if I move forward, I will have 9 multiplied by 5 by 4, which is equal 36, and 9 by 4 is repeated here from 4 by 9, and 12 by 3 is similar to here, 3 by 12. So we can limit the loop, to be within the range of the square root of the number, if this number is perfect square number. Perfect square means that two equal numbers, when we multiply them together, we will have the number. And if the number is not perfect square, meaning that the number cannot be obtained by multiplying two equal numbers, for example, for this 18, which is equal to 1 by 18, which is similar to 2 by 9, or 3 by 6, and these are repeatable, in 6 by 3 to this, 9 by 2 to this, and in the middle we will have the square roots of that number multiplied by the square roots okay, of that number. So we can limit the loop. Instead of going from the range of 2 to the end of that number, we can go from 2 to the square root of that number, okay? And in this case, I can multiply or I can computationally optimize my natural number. Remember, this it takes like from 8 to 9, from 8 to 10, based on my computational source. I will, for example, natural numbers. I want to just to repeat what I had before, 2 and 1000. Okay, these are the natural number, and I want to define, okay, define the prime, okay, numbers, okay, which is a function that will accept a number as an argument. Then I want to add if condition, if num equal 1, okay, and number one is not as it's not considered as a prime number, then I would return nothing but false. Okay, then okay, I want to identify the maximum divisor. Maximum divisor is the square root, so I have to import math, okay, and I want to say max divisor will be, okay, this will be math, okay, dot square root, okay, of what? Of the number. So I consider the square root of the number, but for example, if the number is not this perfect square like 18, then we will have a floating point. So we will round this number down to the nearest integer number by using math.floor to round the number down. Then we can add 1. Okay, so I can loop here for I in range. Okay, we will start our range from 2 to here maximum divisor plus 1. In the past, in the previous example, we used the range from 2 to none, but here I reduced the for loop to be to till max plus 1. Then I use the same thing. If num, okay, modulo I equal 0, then I will return false, okay, else I will return, okay, I will return true, okay, and I can use the same thing for primes here, which will be list of filter. Okay, I use this just to unpack, and I want to use the prime numbers. This function, I remove the parentheses, and I want to apply to the natural numbers, and I want to print the primes. Okay, and I will have the same result. But if I will loop, for example, okay, for example, if I want to import time here, just to see how the performance can be improved, and when I use a star, which will equal time dot time to start, okay, as what we said, okay, then I want to import time, okay, here, and if I use for I in or for, let us use n to be the similar for n in range, okay, which will be 1 to 50,000, okay, then I want to recall the prime numbers function, okay, and to be applied to n, then later I want to print, okay, time dot time, the s2 minus start, okay, and remember in the previous function that loop among the whole range of number, we will have 8 to 10 seconds, and we now have max divisor, which is the half of the range of the number. We will optimize the loop, okay, and we will have now 8%, okay, and not 8 seconds. It's like roughly less than 1 second, okay. This is like 0.08 seconds, and it could be like 8 milliseconds, okay? And we optimize this because we loop till the maximum divisor, till the half range of this number, not from the above number. Remember that we can also optimize the same result, okay, when I use, for example, if a number equal 1, then it will return false. If, for example, num equal 2, then I will return true, because true within the prime numbers, okay. And let us add this. Look at this. If the number is greater than 2, and the remainder, okay, the remainder of the division between the number and 2, okay, equal 0, meaning that if the number is even number that accept the division by 2, then return false, okay. And then we will have the maximum divisor, and I loop here from 3, not from 1, okay. And we can loop from 3 and tell the maximum divisor, but remember, we already have if condition that will consider the whole even number. So I start from 3 and I take 2 steps to 5. So I can loop here over the odd number from 3 to 5 to 7. Why I skip this even number? Because already I have another condition for them, and that will will improve the performance more and more. And we can see here it was 0.8, now it is 0.6, and we have the same result. That's for today's tutorial. We learn together what are the natural number, which is the set of all number, okay, starting from 1 to infinity. But for our example, we highlighted the prime numbers, which are the range of numbers started from 2 to infinity, but these numbers only accept the division by 1 or by itself. Otherwise, we will have floating numbers as a result of the divisions. And we learn together how can we code the prime number function that return true and false in case of a prime or non-prime numbers. And we learn together how can we pass this function to built-in filter function to do filtering to series of the natural numbers, and we unpack the result finally, and we have this, and we learn together how can we optimize our computational performance. Thank you for your participation in this YouTube channel. Please share this video among the new beginners who want to learn Python for free. And see you next tutorial, where we want to introduce random walk algorithm using Python function.